Okay, so like I told you in class the other day, the first part of this video is not going to reference the sheet that I gave you in class that's labeled 12.2. The reason why is that this video is going to cover sections 12.1 and 12.2. So the first part of this unit is just vocabulary. And so I didn't print out a sheet with all of this stuff on it. I just wanted to make reference to it in this video so that when you hear or see certain words, you know what they mean. So the first thing is that a solid is any 3D figure. So if it has a length, a width, and a height, then we're talking about a solid. So it's a 3D figure. So when your book refers to a solid, they're just talking about a 3D figure. And what we're going to do in the rest of the unit is we're going to find these 3D figures. We're going to find their surface area and volumes. The next word here is called polyhedron. That is a solid, a 3D figure, where all of the surfaces are polygons. So in other words, they're rectangles, or they're triangles, or they're pentagons, or they're hexagons. So it's a 3D figure where all of the side lengths are, all of the flat surfaces are polygons. So these two figures that are directly below, we've got an example of a pyramid and a prism. So a prism has two bases. So a rectangular prism is like a box. We could also have a triangular prism. We could have a hexagonal prism. We could have a pentagonal prism. What you'll notice is prisms are always named by their bases. So this is called a rectangular prism because its bases are rectangles. The difference between a prism and a pyramid only has one base. So this is called a triangular pyramid because it has one base that's the shape of a triangle, and then we come to a point on the top. So coming down, parts of a polyhedron, you'll hear me say flat surfaces, which are called faces. You'll hear me say edges, which are the intersection of two faces. So if I was talking about a face, I'd be talking about the whole flat surface on the top. That's a face of the polyhedron. I've got another face here that I'm going to color in. When we talk about an edge is where those two faces intersect. So you're not going to hear me say sides of a polyhedron because that's very ambiguous. It's not specific. So faces are the flat surfaces, and edges are where those surfaces intersect. And then the last one down here is what a vertex is. A vertex is a corner of the polyhedron. This particular slide gives you just a bunch of ideas of what these things are going to look like. Remember, prisms are two bases, and pyramids are one base. That's the difference between the two. So you've got a rectangular prism, you've got a triangular prism, and then a square prism, which is also called a cube. Remember, these prisms are named by the shape of their base. So this middle one here has triangle bases. That's why it's called a triangular prism. Same thing's true for pyramids, except they have one base and they come to a point on the top. So we've got here on the right-hand side, it's called a pentagonal pyramid because the base is a pentagon and then it comes to a point on the top. Something that's important to remember is that not all 3D figures are considered to be polyhedrons. A polyhedron is a 3D figure that has all polygons as its side lengths. So anything with a curved surface is actually not considered to be a polyhedron. Polyhedrons have all sharp edges. So a cylinder has circular bases and it's curved, so it's not a polyhedron. Cones have a circular base and it's a curved surface. Same thing with a sphere. So They're not technically called prisms or pyramids, but they are still 3D figures, and we are still going to find their surface area and volumes, just like we will with prisms and pyramids. And again, this entire part of the video is just getting you used to seeing some vocabulary, so that when I pull out the word prism in class, or if your book uses that word, or if a test uses that word, or if the ACT uses that word, then you'll know what they're talking about when they say prism. Prism is a two-based figure. A pyramid is a one-based figure. What we're going to talk about today is how to find the surface area of a prism and a cylinder. In middle school, you learned a way to do this, and I call it the elementary way, the baby way. So what you did was you unfolded this box in your mind, or your teacher probably had you draw it, or maybe it was drawn for you. And what you get is something that looks like this. If I unfold this box, this figure on the right is what it looks like. And what you did in middle school was you found the area of this, you found the area of this, you found the area of this, you found the area of both of these, and you found the area of this. And what your teacher probably had you do was just add all of the areas together. So we're not going to do that in this class. We're actually going to learn one formula that's going to find all of those rectangle portions together, and it's going to add them all together for us. The net, or the fold out of a cylinder, looks pretty similar. If I unfold a cylinder, your teacher in middle school probably had you find the area of the circles, and then probably had you find the area of the rectangle here. And what you did then was just added those three pieces together, and that gave you the surface area. So again, what we're going to do is we're going to learn one formula that's going to do all of that for us at once. So now this should be the formula, or the sheet that I gave you in class. So there's one formula for any two-based figure. The same formula can be used for both prisms and for cylinders. That formula is right here. Surface area equals 2b plus ph. What you need to know is that B stands for area of the base. So whatever shape the base is, you're going to find that area. The P stands for perimeter of the base. So whatever shape the base is, you're going to find that perimeter. And then we're going to multiply by the height of the figure. Very important to know is that the height of the figure is the distance between the bases of the figure. It's not necessarily how tall the figure is. It's the distance between the bases of the figure, not necessarily how tall the figure is. And you'll see what I mean by that when we get into a couple of examples where the height of the figure is not how tall it is. So let's do our first one. The first figure that we're going to find the surface area of is a rectangular prism. So what we're going to do first is we're going to identify that my bases are these rectangles on the top and the bottom. And all we're going to do for big B here is find the area of that rectangle. So we should know how to find the area of a rectangle. It's just length times width. And in this case, I should say, 3 times 5 is going to give me a big B of 15. The next thing we would want to identify is what's the perimeter of the base. So how far is it around the entire base? So this rectangular base has 4 sides. So we would want to add all 4 sides together. 3, 5, 3, and 5. And if you add those together, you get a perimeter of 16. And then the last thing you'd want to identify is what is the height of the figure. Since we said that the top and bottom rectangles were the bases, that means the height of the figure is the distance between the top and bottom, which is just 8. No work to show for that. We're just identifying that it's 8. Once we know all of those 3 pieces, all we have to do is plug the numbers into our formula. And it's just 2b plus ph. So if I plug those numbers in, The B was 15, the P was 16, and the height was 8. And all I have to do is a little multiplication and some addition. So if I multiply and then add, I get a total surface area of 158. And since I have units in the problem, I would need units in the answer, and it would be in inches squared because we're finding an area. Anytime we're finding an area, it's going to be inches squared. So that would be my final answer for the problem, 158 inches squared. In the next figure, we have a triangular prism. So the reason that this is called a triangular prism is because the shape of the bases are these triangles on the front and the back. Now, how do I know that the triangles are the bases and not the rectangle that it's sitting on? The bases of a prism are always going to be the two parallel faces of the same shape. So notice that we have two parallel flat surfaces on the front and the back, and they're both in the shape of a triangle, which means that those are the bases, and that's why it's called a triangular prism. So if I want to find the area of the triangle face, the formula is 1/2 base times height. So looking at the triangle, it's a right triangle. And so if I want the area of the right triangle, it's just 1/2 base times height. Base and height in this case are 3 and 4. So my big B in this case is going to come out as 6. It's just the area of a triangle. The perimeter of the triangle would involve adding up all 3 sides of the triangle. Well, notice that we only know 2 of the sides of the triangle. So if I need to figure out what that third side is, I'm going to have to use Pythagorean theorem, or I'm just going to need to notice that that third side is part of a Pythagorean triple. If you don't know your triples, you can always do Pythagorean theorem. If I do 3 squared and 4 squared, that comes out 25. And if I take the square root, we get a value of 5, which means this is a 3, 4, 5 triangle. So if I want the perimeter of the base, I just need to add up 3, 4, and 5, because it's the distance around the triangular base. If it's called a triangular prism, the big B is going to be the area of the triangle, and the P is going to be the perimeter of the triangle. In the first one, it was a rectangular prism, so the B was the area of the rectangle, and the P was the perimeter of the rectangle. So the name of the prism tells you what you're finding for big B and P. The last thing we need to identify here is what the height of the figure is. Now you have to be careful with this one, because the height of the figure in this case is not how tall the figure is. The height is always the distance between the bases. So if my bases are the 2 triangles, the height of the figure is going to be the distance between those triangles, which in this case is 2. Remember, height of the figure is not how tall the figure is. It's the distance between the bases. So if I plug everything into my formula, 2b plus ph, the numbers I found, my big B I found was 6. So 2 times 6. pH would be 12 times 2. And if I do a little multiplication and some addition, I get 36. Now notice there are units in the problem, which means that my answer has to have units. Since it is in meters, everything's going to be meters squared. Flipping to the back, the next figure that we have here is a cylinder. So if I want to find the surface area of the cylinder, it has circular bases, which means that my big B here is going to be found by doing the area of a circle. The area formula for a circle is pi r squared. So r is always the radius of the circle. In this particular case, they don't give me the radius. They give me the diameter as 12. We should know from previous knowledge that then the radius is half of that, which is 6. So if we plug 6 in for the radius, all this takes is a little bit of calculator work. So we're going to do pi times 6 squared, and I get 113.1. The next thing that we would do then is find the perimeter of the base. When you're talking about a circular figure, the perimeter of a circle is always the circumference of the circle, which is found by doing 2 pi times radius. So we used a radius of 6 to find the area. We're using a radius of 6 to find the perimeter. So if we again put this in the calculator, I get a 37.7 value for my p. Then the last part of the problem is to figure out what the height of the figure is. Remember, height of the figure is the distance between the bases, not how tall the figure is. So the distance between the circular bases is my value there of 10 on the bottom, because this cylinder, this can, is laying on its side. Once I've identified all of those pieces, all I have to do is plug the numbers into the formula. 2b plus ph. So 2 times 113.1 plus 37.7 multiplied by 10. And I get a final value of 603.2. Again, there are units in the problem, which means that the answer must have units, and that unit will be squared because we're talking about an area. Last problem will be the most difficult one. It is a hexagonal prism, which means that it is a two-based figure where the bases are both hexagons. So what I'm going to do here is identify that I know that this hexagon that I'm outlining in purple is my base. So what I'm going to do is I'm going to make another picture over here so it's a little easier for me to figure out the area of it. So all I've done is recreate what that base looks like, and all I know about the base is that the side lengths are 6. So if we do what we did in the last class, where we found the area of a regular polygon, we drew in a triangle. I know since the entire side length is 6, that the base of the triangle is half of that, which is 3. This angle here on top, I need to figure out. We figure that out by doing 360 divided by double the sides, which is going to give me 30. And then the only thing I need to figure out is what the height of the triangle is, so that I can then find the area using the area formula for a triangle. So if we do that, we get 5.2. So what I want to do now is find the area of that little triangle. That's found by doing 1/2 base times height. And the area of that one little triangle comes out as 7.8. And then we have to figure out, just like last class, how many triangles would I be able to make. Since it's a hexagon, I'd be able to make 12. And so 7.8 multiplied by 12 gives me an area of 93.6. So that is the area of your base. So I'm going to come back up here, and I'm going to insert that there. Now the perimeter of the base, since the base is a hexagon, and it's a regular hexagon, I know that all of these bases, or all of these edges, are 6. So all the way around, there are 6 sides. They're all 6, which gives me a perimeter of 36. Then the last thing I'd need to identify is the distance between the bases. The distance between those hexagon bases is that distance of 8. And once I've identified all of the numerical values, all I have to do is plug them into my formula, 2b plus ph. So we get 2 times 93.6 plus 36 times 8. And again, that just requires a little bit of multiplication and then some addition. and I get 475.2. Since the units in the problem were meters, that means that my final answer has to be in meters squared. If any of the problems don't quite make sense, if there's anything that you want me to re-explain, make sure you make note of that so that you can ask about it next class.